Selection of PV system components. At the end of this lesson, you will be able to calculate the rating of PV system components for a site. Oh no, not again. The frequent power cut is highly annoying. This damages all my devices.
Are you frustrated due to often power failure? Want to get rid of this problem? We, Sunshine Solar Manufacturers, are here to present you our brand new PV system that will light up your world and save your money. Want to experience the power? Don't sit back and wait. Call the number shown on the screen to speak to our customer representative who will guide you through the process. Hello, Sunshine Solar Manufacturers. How may I help you?
Hello, Peter here. I just saw your ad about solar PV system. I'm in need of one at my home.
We are glad you called us, sir.
Could you send me the quotation?
Sure, Mr. Peter. But before sending you the quotation, we need to visit your home and know all the electrical appliances so that we can decide about the solar PV system sizing.
Okay then. You're welcome for a visit. The address is W248 2nd Avenue, Tenia.
Thank you, Mr. Peter.
Hello, Mr. Peter. We are from Sunshine Solar Manufacturers. Hello, come in. As I can see, there is a 18-watt fluorescent lamp with electronic ballast, a 60-watt fan, a 180-watt refrigerator, a 75-watt television. Can you tell me how many hours these appliances will be in use per day? The lamp will be used for 4 hours, the fan will be used for 2 hours, and the refrigerator for 12 hours. The television will be used for 6 hours, Mr. Martin. Why is it necessary to collect these details? Sir, based on the overall usage of the electrical appliances, the solar PV system will be designed. Well then, we will send you the quotation as soon as possible. We need to send a quotation to Mr. Peter regarding the installation of solar PV system. Here is the detail for the usage of the electrical appliances in his house. As far as I have observed, 12-volt DC, 110-watt peak PV module will suffice to power up the system. Also, it is currently available in our stock. That'll do. The usage of the total appliances in Mr. Peter's house are a 18-watt lamp that is used for 4 hours plus, a 60-watt fan that runs for 2 hours plus, a 180-watt refrigerator that runs for 12 hours, and a 75-watt television that runs for 6 hours. In total, we get 2,802 watt-hours per day. So, the PV system should be capable of delivering 2,802 watt-hours per day to Mr. Peter's home. Also, there are possibilities that the solar module may not produce enough supply due to weather or less sunlight absorption. Hence, it is vital that the PV panel should have the ability to produce excess power of at least 30% to meet the load demand in both summer and winter season. So, 30% of 2,802 watt-hour per day is 840.6 watt-hour per day. So, the total energy needed by the PV panel is 2,802 plus 840.6, that is 3,642.6 watt-hour per day. But for the sizing of the panel, total watt peak of the panel should be determined. The power generated by a solar module under full solar radiation under set standard conditions referred as watt peak. To know the total watt peak, the total watt-hour needed per day should be divided by the power generation factor of the area, which is 3.4. Thus, dividing 3,642.6 by 3.4, the peak watt of the panel is 1071.353 watt peak. By knowing the watt peak rating, we can easily calculate the number of PV panels. For this, the calculated watt peak should be divided by the rated output watt peak of the available PV module. Therefore, dividing 1071.353 by 110, we get 9.74 modules, which can be rounded off to 10 modules. As per our evaluation, the entire system at Mr. Peter's house can be powered by 10 modules of 110-watt peak PV module, I presume. Let us now determine the size of the inverter. The size of the inverter depends on the total power used for the appliances in Mr. Peter's home. Thus, calculating the total power usage of all the appliances is 333 volt ampere. The size of the inverter should be considered more than the calculated value, as it should be able to handle the increased load. Hence, the size of the inverter should be considered 30% bigger than the total watts of appliances. That is, 333 into 30 by 100 is equal to 99.9 volt ampere. Therefore, the size of the inverter is 432.9 volt ampere. So, the size of the inverter should be 500 volt ampere. Now, let us determine the size of battery. The ampere hour of the battery should be determined based on the power produced by the panel and power distributed to the load. For PV systems, we can select deep cycle battery as it is specifically designed in order to discharge power till its low energy level and rapid recharge. The battery should be able to operate the appliances at night and cloudy days, as the PV system will not be able to produce output power. Hence, the ampere hour of the battery should be larger to supply a few more days as per the customer requirement, and these additional days are called days of autonomy. To calculate the required ampere hour of the battery, the total power used by the appliances is divided by battery loss into depth of discharge into nominal battery voltage multiplied by days of autonomy. Mr. Peters said that the battery should sustain for 3 days. So, the battery capacity is equal to 2802 divided by 0.85 into 0.6 into 12 volts multiplied by 3. Hence, the capacity of the battery should be equal to 1373.53 ampere hours, which can be rounded off to 1500 ampere hours. The nominal voltage and ampere hour of the battery which we have considered is of 12 volts and 150 ampere hours. The number of batteries that are needed is equal to 1500 ampere hours divided by 150 ampere hours. So, the number of batteries are 10 batteries. These 10 batteries should be connected in parallel to the PV system. The sizing of solar charge controller should match the voltage of the PV panel and battery. Also, it should be able to handle the short circuit current ISC of the PV panel. While considering the configuration of the chosen PV module, the short circuit current ISC is 7.5 ampere. Therefore, it should possess at least 30% excess of current handling capacity. Therefore, the rating of the charge controller is the product of the total short circuit current of the PV panel and the 30% of the total short circuit current of PV panel. Therefore, the total current from PV module is equal to 10 strings into 7.5 ampere. So, we get 75 ampere. 30% of total current is equal to 75 into 30 by 100 is equal to 22.5. Therefore, solar charge controller rating is equal to 75 plus 22.5 is equal to 97.5 ampere. By rounding off, we get 100 ampere. So, the solar charge controller should be rated 100 ampere at 12 volts. We have calculated all the details that are required in the quotation for Mr. Peter's home, I believe. The cost of one PV module is $75. We need 10 modules, therefore $750. The cost of one battery is $34. The number of batteries needed is 10, so it costs $340. The cost of the 500 volt ampere inverter is $75 and the cost of the charge controller is $170. To sum up, the total price for the installation of solar panel in Mr. Peter's home is $1,335. Send the quotation and get the follow-up. Sure, I will make arrangements and follow it, sir. Summary. In this lesson, you have learnt about the PV panel should have the ability to produce excess power of at least 30%. The size of the inverter depends on the total power demand. The ampere hour of the battery should be larger to supply few days as per the customer requirement, ISC of the PV panel, and the rated voltage of PV panel. Battery should be considered while selecting the charge controller.